Hello, what machine is that?
This is a dynamo
How does it work?
by the utilizing magnetic force.
What is it used in everyday life?
Wait, I close the door. Many, one of them to cool the room.
Hey, what are you doing? Planning about the dynamo to this person. Are you interested about this machine? Yes, I am very interested.
In the theory, a generator is a machine that can convert mechanical energy into electrical power by means of electromagnetic induction in its implementation. The electrical energy generated in the generator engine is obtained from the prime mover and also a component called the alternator. With a very good design, the generator can supply electrical energy and make it a priority load.
What are the components?
Now the component of an electric motor and its function. The first is the stator. The stator is included in a major component of the electric motor because this component will directly intersect with a motor performance. The stator is a static copper winding and is usually located to surround a main shaft. The function of this stator is to generate a magnetic field around the motor. The component is known to consist of several iron plates. The slab appears to be wrapped around a piece of copper. This copper will also be connected to current source. So the winding will be powered by electric outrun. So it will present magnetism in the stator. A motor generally has 3 stator coils. It depends on the capacity of the motor. The more the number of turns in the coil, the greater the magnetic field that will be generated. This, of course, will greatly affect the speed of the motor.
And then,
No, I will explain. Get to know the component of an electric motor and function is the first the rotor coil. This section will look very much like a stator for the difference. This rotor is a copper winding that has dynamic property. This is because winding look attached to the main shaft or there is a main shaft of a motor that will spin. So it the same with a stator coil, the more of the number of turns is the rotor. The bigger the rotation that will a big generation it general a copper with a very small diameter will be used. The end of the winding must be connect direct to another rotor which is located at the end of the main shaft.
so that is, I also have several dynamos at home that are used for daily activities, include for work needs. So I each dynamo the same, or is there a significant difference?
Yes, as dynamo has a different power or torque depending on the copper winding in the dynamo.
Are you still confused?
Yes, I'm still confused.
Maybe if you still confused, you can looking at YouTube. I have a channel about dynamo motor. Now, you can looking at this channel about dynamo. You look. Yes.
Magnetic fields to produce electric power. Ships, cars, and motorbikes use alternators to charge their batteries. Toys, power tools, and bicycle lights use dynamos. To understand alternators and dynamos, we need to know about alternating and direct current. In direct current, electrons flow in only one direction, whereas in alternating current they constantly change direction. So you may want to watch this video first. In this video, we're going to look at how a change in magnetic field is used by an alternator to generate an alternating current, and a dynamo to generate a direct current. That's pretty easy to remember. A for alternator and alternating current, and D for dynamo and a direct current. Before we start, you should already know that when a conducting wire passes through a magnetic field, a potential difference is induced in the coil of wire. If the wire is a complete circuit, then a current is induced. Whether we induce an alternating or direct current is to do with these rings here, called commutator rings. This is an alternator, because the wire coil is connected to the commutator rings that are complete, whereas seen now, there is one split ring commutator. This is a dynamo, and so induces a direct current. When the wire coil passes through the magnetic field, a potential difference is induced. It's important to see this part of the wire coil always connects to the first commutator, and this part of the wire coil always connects to the second commutator. When the wire coil cuts the magnetic field horizontally, the potential difference is a maximum. As the coils carry on moving around, the potential difference decreases until the coil is completely out and not cutting the magnetic field at all, and so the potential difference drops to zero. As the wire coil keeps moving around and starts cutting the magnetic field again, we get a potential difference once more. Because the two sides of the coil are now moving in the opposite direction to what they originally were, so the blue wire is now moving down and the red wire is now moving up, the potential difference has reversed direction. It's now negative. Hence we have alternating current. So let's now look at the split ring commutator seen in dynamos. The blue side of the coil is moving up and starts off connected to this half of the commutator, and the red side of the coil moving down starts off connected to this half of the commutator. The potential difference graph looks like this. So maximum potential difference when the coil is cutting the magnetic field like this. And as the coil rotates out and isn't cutting the magnetic field anymore, we have a zero potential difference. The big difference is what happens as the wire coils keep rotating. The side of the coil moving down is still connected to the left half of the commutator, and the side of the coil moving up is still connected to the right half of the commutator. So the part of the coil changes which commutator it's connected to, but the commutators stay the same, left side moving down and right side moving up. The direction of the potential difference and current do not change in dynamos, hence the bouncy graph that always stays positive. This is what one complete rotation looks like on each potential difference graph. Let's finish by quickly looking at how these graphs can change. If we increase the size of the magnetic field, then the size of the current increases. This also happens if we increase the number of turns on the coil, or the area of the coil, and if we increase the rotation speed of the coil, then we increase both the size and the frequency of the current. So there we have alternators that generate alternating current due to having two commutators, and dynamos that generate direct current because of having one split commutator.